Are there any people that don't know Slavic language in the room? A lot? Okay. So I try to speak English and ask me questions if you want translation. So my topic today is very interesting probably to many people. It's zero knowledge, what it is and how to use it. So this is what we're going to go through. Before we start, my name is Maksym Petkus, and I'm a blockchain engineer at Chronicled. It's a San Francisco-based startup. So what if I told you that transparency is the thing that is most beneficial to the blockchain? Is also it's the main issue because of which no business use cases is actually successfully deployed on the blockchain. So what I mean by that is blockchain is shared database, which basically means that everyone sees everything, and many speakers already touched on this. So, for example, if Alice sold container of gold to Bob, everyone on the network will be seeing this, and this is what usually people call business intelligence. And companies don't want to share this business intelligence because they're losing their competitive advantage. So, same thing. Carol sells 1 million of shares to Dave at this price. So basically, disclosing whole information about deal. So what if you try to solve the problem with pseudonymity? So basically, if I create pseudonyms for each different company and use like addresses in Bitcoin, basically, you sort of hide the name of company, but usually it's very easy to correlate with real-world operations. So basically, you know the timing when some deal happened, and you see what happened on the blockchain, so you can correlate the data and easily disclose those pseudonyms. If you try to use obfuscation, then it means that there's no business logic. So for example, if you hash in some data to the blockchain, you cannot have any business logic. It's just like timestamping that information. So basically the conclusion is if you use blockchain and you want to have logic, there is no privacy. So does that mean that this is a fail of permission blockchains overall? I think it's not, and something magical happened in around year 1982, where zero knowledge proofs started, like field of zero knowledge proofs started to emerge, and a lot of new research started to happen. And what's zero knowledge proof at all? So basically, the way to illustrate that is given this example. Let's say if I give you a map of some country, like imaginary or real, that you don't know, and I told you that there is a city with some particular name, but I don't want to share with you where's the location of the city. So basically, I can do a zero knowledge proof to you that this city is really exists on this map, and there is like thousands of different cities and towns. So what approach you can get is you can cut a hole in the very big piece of paper, bigger than the map. You can put this piece of paper over the map and show me that particular name. For example, this is Desful, is so small town in Iran, and you can show that basically if nothing will have been in the room, now you've proven to me that yes, there is such a city on this map, but I don't know where it is. So you disclose no information about where it's located. So, and you can try for yourself. This video, yeah, this is the city. So it is there. Other example of zero knowledge proof is using this 2 cards example. So if I give you 2 cards, but not showing the cards, like giving you the back side of the card, and I want to prove you that those cards are different. So what we can do is like have like a simple protocol. Basically, you take cards behind your back, and either you switch. You have like in 2 hands. You don't see the cards. Either you switch them behind your back, or you don't switch. So this is your decision. And basically, you show me multiple times, like this. We repeat, and I tell you whether you switched or not. So basically, following this protocol, there is some chance of me being lucky. So each time I just guessing. But the more we continue this protocol, the more you convince that I'm not lying. And this is also called interactive zero-knowledge proof protocol. What about mathematics? How actually it works? So this is like a simple math example. It's not correct. It's not what actually happens in zero-knowledge proofs, but just to illustrate how it works, like in simple terms. So basically, if I want to prove you that there is two numbers, for example, in this case, 2 and 5, and their sum equals 7, I want to prove you that I have some, basically the statement I want to prove to you is that I have two numbers that I summed up, and yeah, this is basically my statement. So what I can do to prove you that I summed up two numbers, for example, it can be balances of the Bitcoin account, for example. So I proven to you that I sent two different, so I consume, for example, two different outputs of Bitcoin transactions, and here's their sum without revealing what was the input. So I could raise it into exponent, like let's say number 3, and by this, so I raise number 3 to the exponent of 2, 5, and 7, and I give you results of those exponentiations, and basically, this is again simple. It's not like it works, but the idea is that I give you encrypted numbers, and you cannot go back. You cannot find out what's the original numbers, but you actually can check that it was addition. So now you can multiply those two numbers, and you will see that the result is corresponds to the numbers I sent you. So now I'm proven to you that yes, I added those two numbers. Other cases, multiplication proof. So let's say I want to prove that I multiply two numbers. Again, here it's reversed. I'm exponentiating each secret number, and now I give you those encrypted numbers, and you can verify for yourself whether they match. So basically now again I'm proving to you that I multiplied two numbers. So zero-knowledge proof is you can generalize any kind of problem into this type of statement. So what's green is known. Yeah. So for example, we have some function. Let's say it can be a computer program, and everybody knows. Everybody in the room knows what the program is, and you want me. Basically, it's a way to prove that I have some input to that program that outputs that y that you know, and basically by this you're proving that. So this is zero-knowledge proof to a generalized way that I know some x that results in that y. So I love this analogy of black box. So in black box, usually we don't know what happens inside. You know the inputs and outputs of that black box, and zero-knowledge is something similar. You don't know what the input, you know what the logic and what the output. So you throw something that is hidden from you, but you know that if it was real inputs, it will output that values. So that's why I like to call it like blind business logic. And I've been working on something with zero-knowledge proofs, confidential blockchain project. So basically, this is a demo. The idea is that, let's say I want to, in cars example, probably it's not very well visible, but basic idea is that there is a local car seller and there is two participants. And now we will try to transfer ownership over a car. So now local car seller will gonna create new unit, new car, Tesla. It have its own ID. It can be VIN number or anything else. So now we try to generate this transaction. So you saw here the proof generation stage. And now you see there is a blockchain state and also there is transaction. So in transaction you see all the inputs, and on blockchain you see there is random artifacts. So basically you don't know what happened, yeah? So basically on blockchain some third party cannot understand what's happening. And now again, I bought this car from this local car seller, and he transferred the ownership to this car to me. And now let's say this owner, this seller wants to cheat and sell another car with same number to other buyer. And now you can see that transaction resulted in error. So basically, seller cannot transfer the car. And so what zero knowledge allows is that from those random artifacts, you know that seller doesn't possess that car anymore. So and now the last transaction was me transferring the car to the Bob. So you see that from this like randomly looking pieces of information, we can really extract knowledge, and we can follow the rules. So basically, blockchain, zero knowledge allows you to put business rules in the blockchain, but nobody will not revealing the data. So this concept is used in a Ledger project. This is like core functionality, and it's a Drug Supply Chain Security Act in USA, and so we. Now it's like a pilot project. We connect in multiple pharmaceutical companies like Pfizer and others into this network where they will gonna transact. So the idea of DSCSA is basically that end consumer of these drugs should be able to know that they are authentic and that they come in from original manufacturer. So zero knowledge allows to do that. Because if counterfeiter tries to transfer, let's say, try to fake the drug and send it to distributor, basically he will not have the zero knowledge proof that he possesses that drug. So what are complexities for zero knowledge proofs? It's usually it's long design process. It's easy to step out in terms of security because I mean it could look secure, but actually there is a lot of interesting pieces that you can miss, and you basically break your security. It's non-trivial implementation. Also, there is trusted setup stage. Whenever you have your zero-knowledge program, let's call it, you need to have trusted parties to set it up. But there is also a nice protocols for that, and which ensures that if at least one party is not cheating, now you can trust that setup stage. And also proof generations are heavy computationally. So yeah, don't try this at home unless you know what you do. And so for our system, we had reviewers, which is one of them is Alessandro Chiesa. He is actual one of the inventors of ZK snarks. He's in Berkeley. We have Dave Schwartz from Ripple, and Zaki Manyan is known blockchain expert. So what are use cases for such kind of technology? It's supply chain, anonymous ownership. So for example, let's say imagine you have a car and now you can be owner of that car, but nobody knows who's the owner. So basically you can go to the car and like open it and nobody will know like your identity. And chain of custody. So what are the zero knowledge proof schemes available right now? It's ZK Snark. It's bulletproofs, planned to do in Bitcoin probably, and ZK Stark. So the main difference between them is that for Snark you need to have this trusted setup stage. For other ones you don't need, but it comes at very high price. Usually it's much more expensive to use bulletproofs or ZK Starks if your application is complex, or I mean, by complexity, I mean even if it's simple, it's already complex. So this is just a chart from Benedict Bunz, who compares of different proving systems, and as you can see in ZK Snark, the proof size is always constant. Doesn't matter what is the complexity of the program, but in ZK Stark and in bulletproofs, it grows. In one case linearly, another case sort of logarithmically, but yeah. So what we can do, what this technology can allow us to do, it's we can outsource any kind of computation and trust it So you given some, let's say, for example, on your mobile phone, you need to compute something that is very expensive for your mobile phone. So you can send it to the server, it computes and sends back to you, and now you know for sure that it's computed correctly. So blockchain scalability, for example, you can, let's say if you're a miner, you can mine a block, and you can provide the proof to everybody that this block is constructed correctly. So when it travels through the network, now nobody needs to verify that block at all. So basically, if they have this block and the proof, they know they can already include it in the blockchain. Also, like you can use anonymous authentication, like on your website. People can authenticate. You can allow access to your website, and when people log in, you actually don't know which particular person logged in. This is one of use cases. Internet access, so you can gain access, let's say, through Wi-Fi or other point of access and pay for that internet without revealing your identity. Dynamic identities, so you can manage your identity on, let's say, on Ethereum or any other kind of blockchain, and you can update that identity. And the idea is that, that because logic is there, that fingerprint of that identity, you know that it's of correct format, and only correct, let's say, legitimate people could amend that identity. Medical records, similar idea. So even you can prove collision of hash functions. So you can provide two different messages and prove that, yes, they collide, but you don't want to reveal those messages. So you can prove that particular transaction was in blockchain. Yeah, for example, let's say right now, I want to prove you that I had transaction that happened sometime before, but I don't want to reveal you when it happened. So basically, I can prove you that. You can go into subway, metro, yeah, and you can, let's say, right now if you use this card, basically you're revealing your identity. So if somebody was able to track which card you were using, they can track you all the time. So if you use something like this, you can pay for subway without revealing your identity. Yeah, another way is use token, yeah, which is simpler, I guess. Yeah, elections, voting, anonymous elections is very broad use case. So yeah, I believe this is beginning of confidential blockchains. Thank you.